Video number 2 of our next chapter here. This video is really going to be all about some previous terms that we have used in previous chapters that we will reuse this chapter. Now, last chapter we had this huge list of 30 things, all these different theorems and postulates and definitions and who's its and what's its galore. And we're going to reuse some of those terms, and we're actually going to use a term from last chapter that we didn't really use per se. We talked about it, but we didn't actually use it. But this chapter, we will definitely use one of our old properties in a different way. So all the things that this video is going to talk about is basically everything that we will use at some point in this chapter. Okay, so always keep these in the back of your mind. So first off, an angle bisector. All right, angle bisector just divided an angle into two smaller congruent angles. So our bisector was usually a ray, could be a segment, shoot, it could even be a line, doesn't matter. Typically it was a ray, but it goes right down the middle so that we create two smaller congruent angles. Midpoint was basically like our angle bisector of segments. It is a specific point and it divides that segment into two smaller congruent pieces. So we will see the term midpoint used, just like we will typically see the term bisect used, and we'll just have to know what that means and how to apply it to that situation. Number 3, vertical angles will make a comeback. Vertical angles have been with us for, this will probably be the third chapter we have discussed vertical angles, and the main thing to know about vertical angles is you're not really going to be told that you have vertical angles. You're just going to have to realize, hey, I've got two straight lines that cross paths, and the angles that are opposite of each other, those are vertical angles. And what's true about vertical angles? They are always congruent by the vertical angles theorem. So this will be one thing that you will not be told about, that you will have to basically do yourself. Number 4. From the last chapter, alternate interior angles. Now, we did have 5 types of angles from last chapter. We had our 2 types of alternates, our 2 types of same sides, and our corresponding angles. It'll really be alternate interior angles that will play the predominant role out of those 5 types of angles. Will there be any other type of angle we might run across? If anything, I would have to say it would be corresponding angles. But I would say 99% of the time, if we are dealing with parallel lines, in which you will either be shown parallel line markings, or you might be told in, say, given information that you have parallel lines, most of the time we're going to be dealing with alternate interior. Okay? That very rare occasion, maybe some corresponding, but hardly ever same side interior, exterior, or alternate exterior angles. But they might pop up. Number 5, perpendicular. You will be told the perpendicular symbol, okay? And if we have perpendicular things, what do we have going on? Well, we've really got some 90-degree angles. Now, sometimes it might just be one 90-degree angle, but if we have a straight line that's connected with a ray, then we get to put 2 90-degree angles. So anytime we're told we have perpendicular, we've got some 90s. Now, this is the one property from last chapter that we talked about, but we never actually really used, the reflexive property. We really used the transitive property a lot last chapter. But the reflexive property, and I put it into context here, how we're going to see it, is let's say we have 2 triangles that are back to back with each other. And these 2 triangles share side AC. So in both of these triangles, AC is the same length as the other AC because it's being shared. So the reflexive property stated that anything is really equal to itself. And so we have this side, and again, I would say 99% of the time, we're going to use the reflexive property in terms of sides. Very rarely you can use the reflexive property in terms of angles. Basically, if you have 2 triangles that share the same angle. And it's kind of tricky to draw, but let's say I have this triangle, and then let's say I have this triangle. Okay, let me highlight here. So this guy versus this guy. Both of those triangles share exactly this bottom angle down here. So that would be a reflexive property using angles. Very rarely, again, will that pop up, but it could happen. Those will happen more in our maybe challenge type problems. But for the most part, we're going to be using the reflexive property in terms of sides. So again, if you've got two triangles that share one side, then we're going to say that that side is equal to itself by the reflexive property of either, in this case, it would be congruence, or if I just had an equal sign there, then it would be the reflexive property of equality. And those are the main terms that we're going to use in this chapter. Will there be other terms that'll pop up every once in a while? Maybe. But these are the 6 main ones that you will see over and over and over and over again. And that's all for video 2.